But now we're going to start talking about something called a logarithm. Logarithms are directly related to exponential form. It's another way, we don't necessarily say the entire word, most of the time we shorten it to just log. It's another way of writing exponents. So you will see there the logarithmic form, that is read log base b of a is equal to x. You will notice that b there is a subscript. Okay, it's below the text of the log and the a. What that means, or that is another way of saying b raised to the x power is equal to a. That is another way of saying b raised to the x power is equal to a. Now I call it the swoop. Okay, I start there with the base and I swoop around the equal sign and back up inside the logarithm to come up with that exponential form. Okay, do you see how that works? Start with the base, around the equals, that's your exponent. What's inside the logarithm is what the exponential is equal to. Okay, so the reason why we have logarithmic form, and we'll get into this next week, is all right, what was I trying to say? It depends on where the variable is. First hall, on the way to the media center, on the left, near the college clinic. You're welcome. It depends on where the variable is. Okay, it'll make more sense tomorrow and next week, but for right now, this is all you need to know. So we're going to take these logarithms and we're going to write them in their equivalent exponential form. So if we use the swoop, 3 to the second power is equal to 9. Now, we're okay with that statement, right? We know that 3 squared is equal to 9. Well, guess what? Another way of saying that is that log base 3 of 9 is equal to 2. They say the exact same thing, just different forms. Okay, let's look at number 2. Log base 6 of 2/16 is equal to 3. That is the exact same thing as saying 6 cubed is equal to 2/16. Okay, let's do one more going from log to exponential. Number 3, log base 7 of 1 is equal to 0 is the exact same thing as saying 7 to the 0 power is 1. That's something that you should know. We've been dealing with these properties of exponents. We've talked about when we multiply like bases, we add exponents. When we divide like bases, we subtract exponents. Power to a power, we multiply. Here's another property. Anything raised to the 0 power is equal to 1. Okay, let's look at going from exponential form to logarithmic form. Now, before we start doing them, I'm going to make a note over here. The base of the exponential is always the base of the logarithm. Now, I make that note because it's really easy to go, in my opinion, to go from logarithmic to exponential form. You use the swoop, easy peasy. Going from exponential to logarithmic, you have to think just a little bit more. But if you remember this, it takes one of the numbers out of the process of having to think. So if we have 14 squared is equal to 196, then I know that I automatically start by writing log base 14. The base of the exponential 14 is the base of my logarithm. And then the other two numbers just kind of switch places. The 2 was with the 14. Now it's got to be on the other side of the equal sign. The 196 needs to be on the same side with the 14. And I would check myself real quick. Now that I have it in log form, do the swoop. Base, exponent, what it's equal to. 14 squared is 196. You can check it really quick like that. Kind of like when you check your factoring and you multiply it back out, you can check your logarithmic form. Let's do number 8. 3 to the fourth is equal to 180, or is equal to 81. So the base of the exponential is automatically the base of the log. The other two numbers switch places. Check it with a swoop. 3 to the fourth is equal to 81. We're good. Let's do one more, number 9. Log base 12, because the base of the exponential was 12, so the base of the log is 12. The other two numbers switch. Log base 12 of 12 equals 1. Now that has nothing to do with division. It has to do with powers. All of these have to do with exponents and raising something to a power. That's true because 12 to the first is 12.